Hey everyone, it's your host Russ Altman from The Future of Everything. As fall arrives, many regions are experiencing dramatic weather events. Think early frosts, storms, or unusual temperature swings. Last year, I sat down with Noah Diffenbaugh, an expert on climate change. We discussed the fact that extreme weather is becoming more frequent. It's almost becoming the rule and not the exception. Noah pointed out that there are still things we can do to mitigate the impacts of severe weather. I hope you'll take another listen to this episode to learn about the solutions that are within reach. Before we get started, a reminder to please follow the show in the app that you're listening to. Go ahead and rate and review it as well. Well, we hear a lot about how the climate is changing, the temperatures are going up, and this is having effects on the frequency of extreme events. These are events like heat waves, floods, hurricanes, and other storms. We know that these events also affect humans. It changes where we live. It changes where we build our retaining walls and what we think about a house on the coast. It changes our insurance premiums, and it also affects the cost of electricity. Everything seems to be changing. And it turns out that these changes in weather are increasing at exponential rates. That is to say, it's not just twice what it used to be, it's 3, 5, 10 times what it used to be. Not only that, but the impacts on humanity and humans are also increasing exponentially. That means that we have a lot to do and a lot is going to be changing in the future. Well, Noah Diffenbaugh is a professor of Earth Systems Science at Stanford University. He's also a fellow at the Woods Institute for the Environment at Stanford. He's an expert in climate change and how it's impacting both our physical systems and also how it's impacting humanity. He'll tell us that we are having exponential increases in the extreme events that we all perceive, and we're also having an exponential increase in the human consequences of those events. Noah, one of the things you study is the impact of climate change on human activities. And in fact, you're even looking at which are the ones that are causing the most trouble or the most impact. So where are we seeing the biggest impacts of climate change these days?
Well, at this point, we've had enough global warming that we're really being impacted by climate change everywhere, from the coast to the tops of mountains, from the equator to the poles, at the interior of continents, in all kinds of environments, in cities, in rural areas, people and ecosystems. What's really clear from the scientific evidence over the last 2 decades is that not only is climate change arrived in terms of what we can measure, but it's arrived in terms of the impacts on us.
And looking at your publications over the last few years, I'm very struck that a lot of them, and forgive me for this gross generalization, but a lot of the papers, and they look fascinating, are a climate phenomenon and how it relates to a human activity. So I think you have written papers, for example, about floods and their impact on insurance, or plant water sensitivity and how it affects drought, and vice versa, how drought affects plant robustness. So how do you do these studies, and how do you connect the science of climate change, which is at a global scale typically, with the regional and local effects that we see in terms of these events and these impacts?
Yeah, so this, what you described is really kind of the niche that I have inhabited over the 2 decades that I've been a practicing climate scientist since I started my first faculty job back in 2004. So, really the Intergovernmental Panel on Climate Change is, the UN body that was formed quite a few decades ago now to assess the state of climate change. And it kind of divides the evidence into 3 large categories, and each actually has a working group. So there's what they call the physical science basis. That's working group 1. They have impacts, adaptation, vulnerability. That's working group 2. And they have mitigation, which is really about greenhouse gas reductions and now, other forms of limiting the amount of climate change. So it's really, what are the causes of climate change? What are the impacts on people and ecosystems, and what can be done to curb the trajectory of climate change? So that's kind of the way that the larger world divides climate science, climate research. And, my interests have always really been at the interface, and in particular, the interface of the physical climate system and people and ecosystems. So a lot of where I've been focused, and if one looks paper by paper or looks at the current projects on our lab group's webpage, it actually looks like a pretty disorganized, eclectic, discombobulated grab bag of things we're working on. But the through line really is that we want to understand what's important about the climate system. So we're often looking at the vulnerability of different natural and human systems in order to identify what matters most. And then we're trying to understand what processes regulate, whether it's heat waves or whether it's the length of dry spells or whatever it may be. Then we want to understand how those physical processes respond to global warming.
Gotcha. Okay, and that explains why you kind of do these deep dives. One of the things that comes, and this is kind of a technical question, but one of the phrases that comes up in your work that I need a little help understanding is this idea of climate forcing. Can you take us through why climate forcing comes up so much in your work, and how can we think about what that really means?
Yeah, so that's not my term, but if you think about a world without climate change, a planet Earth without climate change, and that most of planet Earth's history has not had humans, but there's been a lot of variation and change on geologic timescales. And so if we have a climate that's just a stationary climate, really what's driving the circulation of the atmosphere, the circulation of the ocean, the storms, precipitation, heat waves, all of that is essentially we have the equations of motion on a rotating sphere, and we have this energy input, this massive energy input from the sun, right? So one way to think about independent of human caused global warming, all the weather that happens on planet Earth is really the result of this imbalance in the distribution of energy input and energy output, right? So at the planetary scale, without human activities, we tend to, we're pretty close to being in energy balance at the planetary scale. But in terms of the distribution, if you think of the equator, the pole, for instance, right? So there's a net surplus of energy at the equator, and there's a net deficit of energy at the pole, right? And this has to do with the tilt of the planet Earth. This has to do with the seasons that result from that. This has to do with the fact primarily that, if you think about a sphere in space, you're going to get a lot more direct radiation at the equator than you do up at the pole. And then you add in the seasons and you've got, year round at the equator, and you've got obviously pretty extreme seasonality at the poles. And you put that on a rotating sphere, that energy imbalance, and you basically have the energy and the atmosphere and the ocean working out this energy imbalance. So that's without any, that's the baseline.
Gotcha.
And then the reality is that the sun varies in terms of how much, solar output. You got sunspots, and that's varying how much solar output there is. You got volcanoes going off, that put, for short time periods, put aerosols up into the stratosphere, like, Pinatubo being kind of the canonical example of that, but there's, that's been going throughout Earth's history. So you have all these natural forcings.
Yep.
Right.
Yep.
And then we have, humans are emitting greenhouse gases, we're emitting, aerosols. And when we say climate forcing, essentially that's a term. There's a technical definition, but essentially you can think of it as a term for, the change in the energy input to the climate system. And
I see.
Because it's the energy input to the climate system and kind of the distribution of energy going in and energy going out that really drives all the, the regional climate patterns and the weather that we experience. If there's a change to that, for example, from humans emitting carbon dioxide and methane and other greenhouse gases, that's going to force the climate system, right? That's going to change the energy balance of the climate system. And as a result, it's going to change the atmospheric circulation, the ocean circulation, the weather we experience, and in particular, the frequency and intensity of extreme events.
Okay, that's really helpful. So climate forcing is about this, like you have this, okay, it's exactly what you said. There's a baseline, there's human activities, and then there's these jolts, and these jolts force things to happen that might otherwise either not happen or wouldn't happen right away or is on the same time scale. I thought when I read it at first that it was about this thing we've been reading about in the newspaper, which is like geothermal engineering, climate engineering, where you then do things on purpose to alter. And I guess since I just said that, maybe I should ask you about that.
Yeah, so that'd be an intentional subset.
Okay.
Yeah, so you're absolutely right. What the idea of geoengineering is a pretty broad term and has evolved through time, but what certainly has been in the public consciousness a lot recently is the possibility of altering the radiative balance of the planet deliberately. And I mentioned Pinatubo, which was a volcano that went off in the early 90s in the tropics, and among other things, created really amazing sunsets along the California coast. But it also actually cooled the planet at the global scale. It affected the ratio of direct and diffuse light that plants were absorbing, affected plant growth. It had a lot of effects. And for a couple of years, right? So you can think of it about something on the order of a third of a degree of cooling at its peak, and that cooling effect lasting for 2 to 3 years. And so that volcano got studied a lot. And that actually was following up a lot of research on nuclear winter that happened, in the 80s. And I certainly remember when I was growing up, hearing about that on the radio. So in addition to studying global warming, scientists have been studying, what causes, what are the other effects in addition to greenhouse gases. And so the idea of stratospheric aerosol injection, or what you sometimes see as SAI these days, is to basically, the original idea was basically to mimic Pinatubo, and you'll even read papers of where the unit is Pinatubos, so how many Pinatubos of aerosol injection, how many Pinatubos of cooling, how many
it's
Pinatubos
a new unit of measurement
length of cooling. Exactly. You essentially have a unit of measurement that's a Pinatubo, and I don't want to say you can find that in the SI units or anything like that, but you've certainly found this became a benchmark that was used because it was so well studied. Had been used to kind of measure, well, what if we were to, via aircraft or some other mechanism, inject aerosols into the stratosphere, like what happened during Pinatubo and other volcanoes, what would the effect on Earth's climate be? And it certainly, there's no question that blocking out some of the incoming energy from the sun will decrease the energy going into Earth's climate system and have a net cooling effect. And we can talk about some of the challenges and some of the potential side effects. But essentially, we've been conducting an uncontrolled experiment altering the concentration of Earth's the greenhouse gases in Earth's atmosphere, as well as other aerosols and atmospheric constituents that we're emitting, and the idea with geoengineering is to conduct to manage the global climate system by managing Earth's radiation budget.
So I find this fascinating, and if you're willing, and it sounds like you are, let's go a little bit into this. So obviously, people, I'm sure people are saying, well, that we should be cautious here because these are big switches we're throwing, and like unintended events, and like, oh my goodness, we didn't realize this terrible thing would happen when we turned on 7 Pinatubos. So there's a cautionary thing, but I know from the other writings that you've made, like, for example, with close attention to the Paris Accord, that there is evidence that things are kind of getting worse, and they're getting worse perhaps a little bit faster. That's my summary of a very complex literature. So staying on Pinatubo for a minute, does that become a more important and more feasible thing? Because sometimes in the press, this is presented as like crackpots who are trying to do dangerous things, and rich guys who want to play with our atmosphere. But maybe from a scientific perspective, you can tell me, like, how serious are these discussions?
Well, so the scientific literature on it is goes back couple decades, and actually think about geoengineering more broadly. I did my PhD in the early 2000s and read papers on, mirrors, putting mirrors in space. So So this is something that's certainly been explored, not just theoretically, but in the context of formal research, including a lot of a number of different groups trying to figure out now how to do field research and actually deploying field research. So not just modeling, not just sophisticated calculations based on our understanding of Earth's atmosphere and ocean and all the components of the climate system, but actually putting aerosols up into the sky.
Yeah, that's what I was going to ask.
Is
it possible to do little experiments before you do big experiments? I mean, obviously, I'm guessing it is, but it seems like if you build up a knowledge base and data associated with smaller experiments, and so I wanted to ask you if small experiments are safe and doable, and are they being done? Or are there problems? I can imagine international issues in terms of getting everybody on board. And so it's a complex problem, but can you take baby steps before you start turning on the big time Pinatubos? You can see that I really caught on. I love that idea.
Yeah. And this is, the main message is that it's clear that global warming is happening. It's clear it's already impacting us. It's clear, for reasons that I'm very happy to explain, that, additional increments of mean global warming are going to create increasingly rapid increases in the impacts, right? So there's more than one reason that that impacts will accelerate in response to incremental mean global scale warming. I think that's really important for us to be talking about. But what that also means is that we can expect that we are going to progressively be experiencing more and more stress from the climate system. It's going to keep feeling like it's happening faster and faster because it is going to be happening faster and faster in terms of the impacts on us and the impacts on ecosystems. And what that means is that we, if anyone who wants to try to address that challenge, to try to, reduce the damage that we experience from global warming, there are really a few different dimensions in which that can happen. One is the trajectory of greenhouse gas emissions. Greenhouse gas emissions are by far the primary cause of the global warming and climate change that's happening. And so, the more greenhouse gas emissions, the more damage we're going to experience. That being said, even if the Paris Agreement is successful and we hold global warming to somewhere between 1.5 and 2 degrees, that's still more than what we've already had now. And, so there's going to be more global warming and climate change. And that means, we're not adapted to what's already happened. We're certainly not adapted to more. And so adaptation is a really important dimension. And then, the newest dimension I'd say is this kind of, manipulation of the climate system. And there's a lot of rhetorical debates about what that should be called. In addition to geoengineering, or, whether is that a form of adaptation? Is that a form of greenhouse gas mitigation? Right. So there's a lot of rhetorical arguments that some of which is kind of inside the scientific community, but some of which is goes outside the scientific community. But I think I'm not really aware, and I ask this question a lot of my colleagues, and I haven't found anyone else who's aware of where humans have conducted a large-scale environmental intervention that's not directed at the root cause of the problem and not had some surprising, unexpected consequences that weren't entirely welcome. So, there's just a huge number of examples of rampant, growth in the population of this toad or that elk or whatever, right? Like, we've got lots of examples where, things have gone haywire. That's not to say that this wouldn't work, but it's really is uncharted territory. That being said, for those who are concerned that global warming poses existential risks, it's hard to imagine, if that's true, why preventing that level of global warming, why at least researching how to prevent it wouldn't be rational. Now, you'll find that I'm more moderate in terms of my level of my reading of the evidence about the potential for existential catastrophe from global warming. But I do understand that if one sees evidence that global warming threatens the habitability of planet Earth and survival of human civilization, as has been notably said on the record by others, then it's hard to imagine why it wouldn't be worthwhile to investigate whether that could be avoided.
This is The Future of Everything with Russ Altman. More with Noah Diffenbaugh next. Welcome back to The Future of Everything. I'm Russ Altman. I'm speaking with Noah Diffenbaugh from Stanford University. In the last segment, we talked about some of the basics of climate change, why the climate is going up, and how that affects human activities. We also talked a little bit about geoengineering, where humans do things on purpose to try to mitigate global warming and climate change. In this segment, Noah will tell us that adaptation to climate change is something that humans can be good at, but we're actually falling behind these days. He'll also tell us that AI technologies are giving him and his research group the ability to predict extreme events. And so in the future, we may get warnings about heat waves, droughts, and flood surges. So, Noah, one of the topics that comes up in your writing is adaptation. And I presume it's adaptation to climate change. But tell me why this is an important concept and how it's evolved over time.
Yeah, so you can think about adaptation as, actions that people, society take to prepare for climate change, to avoid the impacts of climate change, to adapt to the emerging impacts of climate change. And there's a couple ways you might, do this. One is what in the jargon is called autonomous adaptation. And so, the world's changing and we adapt to it, right? And humans obviously, have evolved to not just survive, but thrive in a huge range of climate conditions around the world. And so we obviously are a very well adapted species, right? Where it's one of our, I'd argue, one of our great skills, one of the keys to our success. So that's like autonomous adaptation, and then you can think about active or intentional adaptation, where sea level is projected to rise to this level, and we're going to adapt by moving away from the coast, or we're going to adapt by building a seawall. Yep. We're going to adapt by investing in community resilience, et cetera, right? And so kind of active adaptation. And I'll say that I started, my faculty career 20 years ago, and back then I was really an adaptation optimist. I mean, I really was confident that if we invested in human development, invested in economic development, that all of that ingenuity that's led to us to be able to live from the Sahara to Antarctica and and everywhere in between would get unlocked, right? And that really, that poverty, was a big barrier, that, lack of other resources was a big barrier, and that, that investments in unlocking that human potential would make up for the increase in climate stresses from global warming. And I was definitely wrong. And the evidence that I was wrong is that, I still think poverty is, global poverty is a much bigger issue right now than climate change. In my, that's not me as a scientist. That's me as a, in terms of things that students say, what should I be concerned about? So we can talk about that if you want. But I was definitely wrong about adaptation, and that the gap between what's happening and what we're prepared for is getting bigger, not smaller. Right? And in fact, we now have a lot more understanding of why that is because of research that's happened in the last couple decades. And one element of this is that it is really pretty simple in terms of statistics. If you think of, not all climate variables have have a bell curve distribution, but temperature most locations is pretty Gaussian. And if you just imagine a bell curve and you shift the mean of the bell curve to the right towards the warmer end, the shape of the tail of that bell curve is exponential. Right? So if we just shift that bell curve 1 degree, we're going to get an exponential increase in the frequency of what used to be the most extreme events. Right. Rare things are way less rare. Yeah. And they don't get more rare. I mean, they don't get less rare at linearly. Right. Just because of the shape of the distribution. And there's tons of research on what exactly the shape of the distribution is in the tail and all that. And actually it turns out that we get a little bit more acceleration because of the shape of the tail in the hot side of the distribution, lots of research in that area. But, first order, just, take a 1 degree of global warming and, distribute it evenly around the world, and we should expect an exponential increase in the frequency of extreme hot conditions.
Yeah, and that really, I must say, it rings for somebody who's lived a while, let's say more than 40 years, it's almost perceptible just obviously in life. Like, you don't need to look around too hard to say, when I was a kid, this stuff happened, and now this other stuff is happening, and it's happening way more.
Yeah. And so that's like factor number one. But then there's a second factor towards this accelerating impacts, which is that, in the last decade in particular, there's been a lot of research using empirical analyses, so econometric techniques, to analyze the relationship between climate conditions and different human and ecological outcomes in real history, right? From the real data, the real observation of what's actually happened. And what that's revealed is that in case after case after case, the relationship between, say, temperature variability or precipitation variability and economic damages, whether it's economic growth or financial costs of flooding, insurance liabilities for the U.S. government and the crop insurance program. I'm mentioning 3 specific papers, but there's violence, intergroup violence, decline in test scores. Just study after study reveals a exponential relationship. So the farther we get out in the tail in terms of the magnitude of the climate event, the greater the impact. So this is a separate
separate exponent.
This is a separate exponent.
If I'm hearing you correctly, you have 2 exponential processes in a positive feedback loop.
Well, yeah, I mean, certainly both contributing to accelerating impacts, right? So if you say, well, it's just a degree of global warming, well, one, we've got more warming over land where we live than over the ocean. So we've got more than a degree of global warming already, more than a degree of regional warming already in a lot of regions. We've got exponential increase in extreme conditions from that, and then we've got exponential impacts from every one of those extreme events. And so now when people say, wow, it seems like it's accelerating. Well, yeah, it is, right? For reasons that are well understood. And so this is why and then I'll give you a third factor in terms of your question about adaptation. So why are we falling further behind on adaptation? If you look at investments, in the Inflation Reduction Act, for example, if you look at international climate finance, for example, so both domestically and internationally, what you'll see is that the investments in decarbonization, right, the investments in energy that doesn't emit greenhouse gases, which is really, really, really important. So I'm not here to say that's not important, but the investments are about 10 times the investments in adaptation. So extreme events are accelerating. Extreme events are the primary cause of impacts. The relationship with extreme events is exponential. It's accelerating. And our investments are we're not making investments to keep up. So even with a linear increase.
Got it. And this is the source of your kind of new pessimism about adaptation. I want to do a switch because I definitely want to hear about how, I know your group is using AI to kind of augment many of the things you've done previously and kind of superpower it. So tell me about AI in your work and what it's enabling.
Yeah, so I have the zeal of the converted, as they say. I'm not a computer scientist. I'm not an AI expert, but I am really lucky to be able to collaborate with experts. And I think if maybe the quickest way to articulate it is if you think about experimentation. Experiments are a fundamental pillar of the scientific method, right? And if you think about the global climate system, our ability to run thousands of experiments like you could in a lab, we just can't do that. We've got one Earth, and we can't run even one controlled experiment on it. And so, a lot of what we know is from theory, and then from using climate models, which are really sophisticated, highly accurate computational models. But we're still not running experiments on the real world, right? And so we're basically running the experiments we'd like to run in the real world using large suites of climate models. And then we compare the results of those climate models with actual observations of the real world.
Right.
So if you want to know, there was a heat wave here on campus in October, and it was 100 degrees hypothetically in October 2024, right? I mean, how much did global warming contribute to that? Right. And so there's a really sophisticated scientific framework to objectively pose hypotheses and test those hypotheses. But that relies on climate models. We can't run a counterfactual world. And so what we're doing with AI or what AI is enabling us to do, is leverage the real observations of the real world in order to ask that question about the counterfactual. So, to put it simply, we train the AI on these climate model simulations, so it learns over a range of global warming. How do the kinds of weather maps you see, on your weather forecasts or on the evening news, how does the outcome from those weather conditions change in response to global warming based on these climate model simulations? And then what we're able to do is we're able to take the trained network, the trained AI,
yep,
and give the real observations of what actually happened, what the actual atmospheric weather pattern was on those days in October here on campus, and then use those real weather conditions and then use the AI to run the experiment about how much the conditions we'd experience on campus would change with global warming. And we're able to do that for extreme events. We're also able to do that for things like the global temperature, for different trajectories of greenhouse gas emissions in the future. How much global warming can we expect, et cetera.
So it sounds, tell me if this is a fair summary. It sounds like the AI is allowing you to ask a broader range of kind of what if questions. What if the past was different, but also what if the present was different? And it sounds like it's also connecting in novel ways measurables that don't come out of climate models, but that you care about. It kind of can connect them together. Is that right?
Yeah, exactly. I mean, I think AI is being used in lots of different ways in climate research right now. And I guess for my research, what I'm really excited about is it's enabling me for the first time now, as I start year 21 of my faculty career, for the first time I'm able to say, I'm making an actual prediction that is testable in the real world.
Right.
And so I'm in year 21, I'm now a scientist.
That's huge. Thanks to Noah Diffenbaugh. That was the future of extreme climate events. Thanks for tuning into this episode. We have more than 250 episodes in our back catalogs, so you can listen to interesting conversations about the future of anything. If you're enjoying the show, a reminder, please tell your friends, family, colleagues about this show. Get them to listen, get them to rate and review. We love growing the audience. You can connect with me on many social media platforms, including LinkedIn, Blue Sky, Mastodon, and Threads. I'm at Russ B. Altman or at RB Altman. You can also connect with Stanford Engineering at Stanford School of Engineering, or more simply, at Stanford ENG.